Let's provide an overview of the manufacturing processes. Manufacturing is extremely important. Making things have been an essential human activity since before recorded history. Today, the term manufacturing is used to describe the fabrication of parts, and manufacturing has been the cornerstone of a lot of the products that have been developed internationally and domestically, and they have pushed technology and economics to new levels every decade. What is manufacturing? The word manufacturer is really derived from two Latin words. One is called manus, which comes from the word hand, and factus, which is to make. The combination of the two basically provide the combination of made by hand, describe the manufacturing methods, fabrication methods as well, that were used when the English word manufacture was first coined around the 1567 AD. Most modern manufacturing operations are accomplished by mechanized and automated equipment that is supervised by human workers. Manufacturing technology is the application of physical and chemical process that allow the alteration of the geometry, properties, or appearance of a starting material to make the parts or products. You will start with a material first, it could be a stock, then you go through the manufacturing process, which will have touch methods, could be machinery, tooling, power, labor, and then that will then result in a processed part, and then this is also then will create scrap and waste. And the idea is with manufacturing economics, which is the other side of things, is that this is the transformation of materials into items of greater value that will include one or more processing or assembly operations. Manufacturing needs to add value to the material by changing its shape or properties. Otherwise, there's no point to the manufacturing process. Here, you can see the starting material, which you have a cost involved, and then you'll process that material, and that process of the material will require additional investment that may include manufacturing processes or touch labor. During the process, that will then result in a process part that can push the economics to new boundaries. An example of a manufacturing a problem here is the artificial heart valve. It starts with a titanium billet and it results in a value added to human society through the manufacturing of a heart valve. Manufacturing in requires having to shape materials or modify materials. Most engineering materials can be classified into one of the three basic categories: metals, ceramics, or polymers. In these cases, in all these three cases, their chemistries are different, their mechanical and physical properties are dissimilar, and this difference will affect the manufacturing processes that can be used to produce products from them. Manufacturing processes it require the processing operations which transform a work material from one state of completion to a more advanced state. And this means that I'm taking a material that is a little bit more immature in state and I'm moving it through the manufacturing process to get by changing the geometry properties or appearance of the starting material to end up with a more mature state. And the assembly operations then come into play by joining two or more components to create a new entity together. So here is a diagram depicting the classification of manufacturing processes. Here on the left, you will see manufacturing processes being depicted. But manufacturing processes include processing operations, assembly operations. So they're divided in two. Now, when I look at processing operations, that can be further being examined by looking at shaping processes, property enhancing processes, and surface processing operations. And from here, we have a further division. So, shaping processes can require solidification processes, particulate processes, deformation processes, and material removal. Machining is an example of material removal. We'll talk about it. Property enhancing processes is another processing operation, and that enhances the properties of a material through, for example, heat treatment. You then have a third aspect, which is surface processing operation, which is part of processing operations. And that allows you to clean and provide surface treatments, coat and provide deposition processes. And now I go down to assembly operations, which is divided in two. You have permanent joining processes and mechanical fastening. And on the permanent joining, you're looking at welding, brazing operations, soldering, and adhesive joining. Then you have mechanical fastening, which is threaded fasteners or permanent fastening methods. We'll be focusing on processing operations, and if we have time, I will go into assembly operations. In the red is where we plan to first focus in this course. So processing operations alter a material's shape. And so here what I'm looking at is processing operations there. And that will require altering the material shape, physical properties, or appearance in order to add value. There's three categories of processing operations. You have the shaping operations, which alter the geometry of the starting material, work material, property enhancing operations, which improve the physical properties without having to change the shape. And then you have surface processing operations, which require or could include cleaning, treating, coating, or depositing material on a surface of that work part. Now, there's four further categories of shaping processes. Solidification process, which it starts with the material as heated liquid or semi-fluid. You can have a particulate processing, which starts the material consisting of powders. And then you have deformed processes, which starts the material as a ductile solid. That's commonly seen in metals. You then have, and that could mean bending a tube, for example. Material removal processes look at starting the material as ductile or brittle solid. And here I depict each of them sequentially. So number one here is solidification process. The second one, I'm applying a force to then create the material. And then I have here the deformation process, starting the material in the ductile solid and then shaping it through some mold that a force is applied to, for example, and then material removal processes, which you can have a tooling that removes material by this shaft rotating. So let's look at the waste in shaping processes. So when you look at shaping processes, which is the one here, which is part of the processing operation, which is part of manufacturing processes, it is desirable to minimize waste in part shaping. Material removal processes are wasteful in the unit operations. Now there have been techniques to try to repurpose them by bringing them, and that's part of the research going on today into the zero carbon emission. Molding and particular processing operations waste very little material, and that's one benefit that these two processes have. The terminology for minimum waste processes is the following. You have net shape processes, which have very little or no waste of the starting material, and there's no subsequent machining required. You then have the near net shape processes when you have a small minimum amount of subsequent machining that's required. So you're very close to the final shape, very small machining to get it to the final product. So two important terminology when it comes to waste processes, net shape processes and near net shape processes. Property enhancing processes. That's the second aspect that is part of processing operations. Those are processes that improve the mechanical or physical properties of the work material. Examples of that is heat treatment of metals and glasses, sintering of powdered metals and ceramics. In this case, the part shape is not altered except unintentionally. The example will be unintentional warping of a heat treated material. For example, I have a part, I apply heat treatment, but then you could have a shape change due to the heating gradients over the material, the thermal gradients, I should say. Surface processing operations is the third one that you see there being listed. That's part of processing operations, which is part of manufacturing processes. The first one is cleaning, which is a chemical and mechanical process that is used to remove the dirt, oil, and other surface contaminants. Surface treatments, mechanical working such as sandblasting, and physical processes like diffusion. Coating and thin film deposition is a great approach because it requires coating to coating surface of that work. And what that does, it provides better performance in operation, like electroplating and painting. It can also provide protection in many cases, like painting can provide protection. We'll discuss those later. And then you have the assembly operations, which I had discussed previously, and we have time, we'll be spending some time there as well. Assembly operations, that's basically taking two or more parts and joining them to form a new entity. Types of assembly operations include joining processes, create a permanent joint, and then that will include welding, bracing, soldering, and adhesive joining. And then you have mechanical assembly, which is fastening by mechanical methods. There'll be threaded fasteners, press fitting, expansion fits. In these two cases, these two types of assembly operation, very important to understand that even though I'm providing these examples, for example, there are research going on today to figure out a way to disintegrate an adhesive that has been previously cured so they can then rejoin again. So I call it permanent joint, but there has been some research trying to reverse this word permanent. And that's again going after zero carbon emissions, trying to be more efficient, trying to save material. So say you put two parts together and those two parts, you made a mistake, but you bonded them or you joined them through welding. Is there a way to reverse that process so we can start over and not lose the material? And then here you can see the welding process, two welders there working it. And then here you have additional operations on the right, like soldering. And then you have threaded fastening approaches used in many applications. Production machines and tooling. Manufacturing operations are accomplished using machining and tooling. The types of production machines include machine tools, like power-driven machines used to operate cutting tools that are previously operated manually. They're more automated today. Other production equipment can include presses, forge hammers, plastic injection molding machines. The production system, people, equipment, procedures are required. In a lot of cases, you need certification to ensure consistency in the production of these systems, structural systems. That constitutes those people, equipment, and procedure are used for the materials and processes and constitute the basis of manufacturing operations. A manufacturing firm must have systems and procedures to efficiently accomplish its production. There's two categories of production systems: production facilities, manufacturing support systems, and then making sure we understand that people make the system work. At the end of the day, it's people that make the system work, and that is required. But you also need equipment that is calibrated, that it has been demonstrated to be consistent, because you don't want products that are inconsistent from one to another. And the more critical to life operations, like aircraft, versus, say, a more benign manufacturing of a ball, depending upon the severity and the criticality, you may require more reliable systems across the board. So here you have the model of the production system. You have here the manufacturing support systems, and you need quality control to ensure those manufacturings are in consistent are coming out consistently. You have manufacturing systems, and these manufacturing systems are part of your engineering materials that come in, and you have manufacturing process and assembly operations that go into these manufacturing systems. This is a symbiotic relationship, and then quality control is part of that. All this together, this manufacturing support you see here with the facilities allow you to provide that finished product. And so now we'll move on to the next topic, which will be machining. Thank you for your attention.